Algebra 1. So you can find this note page on Canvas, or feel free to write this on your own paper. So write on a separate piece of paper. So up to you how you would like to solve these example problems. Totally up to you. But we're going to work through them, and we're going to work through some reasoning. So I'm going to go ahead, I'm going to switch over to pink because I like to use that one. And we're going to talk about this first problem. So I'm going to zoom in just a little bit. There we go. Okay, how should we solve this first problem? And there's something that I want to point out about it, and that is that we have this x minus 7 squared. So that x minus 7 squared tells me right away I absolutely am able to solve this guy by square roots. So the reason I'm going to put down here is that I can isolate this x minus 7 squared. So can be isolated. It's in the form x plus b squared equals c. So that's what I'm looking for there. So let's go ahead, let's use our square roots and solve this guy. I'm going to zoom in for you so you can see the problem. So I need to isolate it, meaning that I have to add 70 to both sides, leaving me with 3 times x minus 7 squared is equal to 75. Divide both sides by 3. On the left-hand side, I have x minus 7 squared is equal to 25. So now when I take my square roots, I have x minus 7 because the square and the square root cancel each other out. But what's really cool about the square root of 25 is that it simplifies to 5, but don't forget that plus or minus. So now when you add 7 to both sides, you get x is equal to 7 plus 5, and x is equal to 7 minus 5. Don't forget that plus or minus. Hey, those are two problems I absolutely can solve. We have x is equal to 12, so there's option number 1. And x is equal to 2 for our second solution. So definitely solving by square roots. Okay, let's go ahead, let's move on to number 2 here. I'll switch up colors. But we're looking at this guy, I'm deciding between factoring. I can't use square roots, and the reason that I can't use square roots is because it has a bx. So I definitely can't use square roots. Now, the very first thing that I always like to go ahead and check for is factoring. So I always like to set up this diamond just to see if it is factorable, and it turns out that this guy is. So factors of negative 35 that are going to add to negative 2 are a negative 7 and 5. So I'm solving it by factoring. It is factorable. And it's something that I always like to check for before I try anything else. The other thing that I'm going to say here is that factors of negative 35 that add to negative 2 exist. They absolutely exist, meaning that it is factorable. So what's so cool about something that's factorable is that it turns into a super easy equation to solve. This guy, we can go ahead and factor it pretty easily. And then once I set that up, switch over to green, this guy using our zero product property, or this guy using our zero product property, has to be equal to 0. So either my green guy, so x minus 7 equals 0, that's one option. Or the purple guy, x plus 5 equals 0. Those are my two zero product properties. Then from there, you can solve both of these linear factors. So x is equal to 7. There's one of them. And x is equal to negative 5. It's my other answer. So we love the factoring ones because they go pretty quickly in terms of solving. Let's move down to example number 3 here. So the first thing is that you would think in your mind, okay, do I have factors of -5 that are going to add to 9? Definitely not. So I cannot factor this guy. I'm going to get rid of these marks though. Okay, so we can't factor it. I can't use square roots because it has a bx sign on there. And completing the square wouldn't be a good option, even though it would work, is that because it would result in a fraction 9/2. So the thing that I'm left with is quadratic formula. And the thing that I'm going to put in my notes is that the middle term is odd. So the middle term is odd and not factorable. So when that happens, when your middle term is odd and not factorable, you definitely want to use the quadratic formula. So why don't we go ahead, we'll zoom in, and we're going to go ahead and solve this guy. So I want to, first of all, write my quadratic formula. Plus or minus the square root of b squared minus 4ac all over 2a. The second thing I want to do is list my a, b's, and c's. So a is equal to 1, b is equal to 9, c is equal to -5. At some point, you guys are going to get so pro at this that you won't have to do those little steps. You'll be able just to plug them in. But for right now, I would really like to see that we are writing our quadratic formula over and over until the point that we memorize it. So I'm starting to plug in our values here. So -9 plus or minus 9 squared minus 4 times 1 times -5 all over 2 times 1. And then from here, we just have a whole bunch of order of operations. I'm going to go ahead, I'm going to solve this guy on the inside, and we're going to do it all in our head. We are going to do 9 squared, that's 81, and then I have -4 times 1 times -5, that's a positive 20. That leaves me with a total of 101 over 2. I cannot simplify that anymore, so I'm simply just going to go ahead and I'm boxing this answer because that is my 2 final answers for my quadratic. Okay. We got a few more that we're looking at here. I'll switch up colors again for you. There you go, for purple. So we could go ahead, we could look at this guy. First things first, check to see if it's factorable. I'm looking at 16 factors of 16 that add to -12. I can't do that. So we're going to go ahead, we're going to say I can't factor. It has that middle bx term. I can't use square roots. But here's what's cool is that, yeah, heck yes, I can use completing the square. And the reason I can use completing the square is because I can make the leading coefficient 1 and, and the middle term is even. So that's what you're looking for when completing the square. It's my personal favorite, so I'm always kind of looking for ones I can complete the square on. First things first, I'd like to divide it all by 2, meaning that we have x squared minus 6x plus 4, and then we start moving some things around, meaning that we have x squared minus 6x, leave a space, is equal to -4. I am going to add a -6/2 squared to both sides of my equation. And this is where we start thinking about some math in our head. -6 divided by 2 is -3. Squared is going to give me a 9. So I'm adding actually 9 to both sides. And the reason that we added 9 to both sides is so that we could factor it into this perfect square trinomial. This is going to give me 5. Now I get to use these square roots. And I love, love, love this because it looks so pretty. I ran out of room a little bit, but we're going to add 3 to both sides. But I'll write my answer over here. So that x is equal to 3 plus or minus the square root of 5. And it just is so nice when you get to complete the square. Looks so pretty. Okay, so we've done a few of them. I'm going to switch up colors here for you again. And we're going to walk through just the last few of these. This last one here, I want us to notice again that it doesn't have a bx term. So we're definitely able to use this square root. So no bx term. And when it doesn't have that middle bx term, I'm able to go ahead and isolate our x squared. So why don't we go ahead and let's do it. So I need to subtract 14 from both sides, leaving you with x squared is equal to negative 14. In order to undo that squared, I have to take the square root of it, and this is why we're throwing this one in. Uh-oh, I ran into a problem right here. So there's a negative inside the square root. And that's my problem, is that as of right now, I cannot do that, meaning that we don't have any real solutions. No real solutions for this guy. This is my answer. So pretty easy and pretty fast when they solve by the square root. Last one for us today, and that's this bottom one. And it seems a little bit tricky, we've seen it a few times on our homework, is that when we see this, don't forget about factoring a GCF. I think I've said this 500 times, is that I love, love, love factoring. So I'm always looking for factoring. I especially love GCFs. So I can factor out a GCF here. And when I factor out my GCF, if you guys can go ahead and see it, we have 3x squared plus 10x equals 0, is that my GCF is x. So then I have 3x plus 10 equals 0. And from there, my exponent disappeared, meaning that I have x, and we'll choose orange, 3x plus 10 equals 0. So using my zero product property, I know that x is equal to 0, that's my pink guy, and 3x plus 10 is equal to 0. This guy's actually already solved, but I need to do some inverse operations over here on my right-hand side. So divide by 3, x is equal to negative 10 over 3. And I'm just going to write x equals 0 down here at the bottom so that my answers are on the same line. And that is all of your notes. Congratulations.